Every successful green hydrogen project begins before electrolyzers are ordered, construction starts, or hydrogen is produced. Developers must first prove that the idea is technically achievable, commercially viable, environmentally responsible, and financially attractive. That requires engineering studies, market assessments, environmental reviews, financial models, and stakeholder engagement. But at this early stage, the project has no operating assets, no revenue, and no certainty of being built. Someone must finance this preparatory work while carrying significant risk. This documentary examines who pays for green hydrogen feasibility studies and how early project funding helps transform ambitious ideas into bankable infrastructure. Every hydrogen facility begins with an opportunity. A developer may identify strong renewable resources, growing industrial demand, or a region seeking cleaner energy and economic development. But the project initially exists only as an idea. Developers must determine whether sufficient renewable electricity and water are available, whether the location is suitable, which technology should be selected, and who might purchase the hydrogen. They must also examine infrastructure, regulations, permits, and market conditions. These early questions shape every decision that follows. Before investors can evaluate the project, the concept must be developed into a realistic opportunity, supported by credible technical and commercial information. The feasibility study is one of the least visible but most important parts of hydrogen project development. Engineers evaluate technology options, hydrogen production capacity, electricity consumption, water requirements, infrastructure, equipment, and construction costs. Financial specialists estimate capital expenditures, operating costs, revenues, cash flow, and potential returns. Environmental experts examine permitting, land use, biodiversity, emissions, and community impacts. Market specialists assess customer interest, hydrogen demand, pricing, and long-term commercial opportunities. Together, these studies determine whether the project should move forward. Without reliable analysis and realistic assumptions, investors cannot properly understand the opportunity or evaluate the risks involved in financing it. Green hydrogen developers face a difficult paradox. They need funding to complete the feasibility study, but many investors require a completed feasibility study before providing funding. During this early phase, technical designs remain incomplete, customer agreements may still be under discussion, and major risks have not been fully assessed. Traditional lenders are usually reluctant to finance these activities because the project has no operating revenue or assets capable of supporting conventional debt. Developers must therefore finance the work themselves or identify organizations willing to support early project preparation. Overcoming this funding gap often determines whether a project progresses toward investment or remains an undeveloped concept. Many green hydrogen projects are announced, but only a limited number reach construction. Early-stage funding is one of the largest barriers. Some developers lack the resources to complete credible engineering studies, environmental reviews, market assessments, and financial models. Others underestimate project complexity or rely on assumptions that cannot withstand investor scrutiny. Without strong preparation, projects struggle to attract governments, strategic partners, development institutions, lenders, or private investors. Technology alone cannot make a project bankable. Successful projects are supported by reliable evidence, realistic economics, qualified teams, and clear development plans. Preparation creates the confidence required to move a hydrogen project from announcement to implementation. Projects move forward when developers systematically reduce uncertainty. They verify renewable energy resources, evaluate water and infrastructure requirements, understand permitting, confirm potential customer demand, and develop realistic financial projections. They also build relationships with regulators, utilities, engineering firms, communities, prospective customers, and funding institutions before requesting major investment. Every completed study answers another question that investors may raise. Each resolved risk strengthens the project's credibility. Successful developers do not simply wait for finance to become available. They prepare the project until funding organizations can evaluate it confidently. Project development is therefore the process of replacing assumptions with evidence and uncertainty with an investable plan. Two developers may select similar electrolyzers, use comparable renewable resources, and target the same hydrogen market. Yet their projects can have completely different outcomes. One may secure financing while the other remains stalled. The difference often lies in project preparation. Successful developers secure land, assess environmental requirements, verify power and water availability, study customer demand, and prepare credible engineering and financial models. They identify risks and develop practical responses before approaching investors. Less prepared projects may rely on optimistic projections without sufficient evidence. Investors recognize these differences. Technology creates the possibility of hydrogen production, but disciplined project development transforms that possibility into an investable infrastructure opportunity. Green hydrogen projects do not develop under identical conditions. Every country has different policies, financing institutions, regulations, infrastructure, energy markets, and investment conditions. Some governments actively support hydrogen through grants, incentives, strategies, and public financing programs. In other markets, developers depend more heavily on international institutions, strategic investors, or private capital. Infrastructure also varies. Some countries have established electricity networks, ports, industrial customers, and skilled project teams, while others must develop these systems alongside hydrogen production. These differences affect project costs, timelines, risk, and available financing. Successful developers understand the local ecosystem and adapt their funding strategy to the conditions surrounding the project. Access to capital influences how a hydrogen project is designed, developed, and financed. Mature financial markets may offer experienced banks, infrastructure investors, clean energy funds, and institutions familiar with large projects. In less mature markets, commercial finance may be limited. Interest rates may be higher, and investors may perceive additional risks. Developers may therefore rely more heavily on grants, concessional finance, climate funding, development finance institutions, or blended structures. Capital availability can influence project scale, development speed, financing costs, and implementation strategy. Understanding which funding sources are realistically accessible helps developers structure projects appropriately from the beginning, rather than designing facilities that cannot ultimately secure financing. Hydrogen projects face different combinations of technical, commercial, regulatory, financial, construction, infrastructure, political, and market risks. No single funding organization is designed to manage all of them. Governments may reduce early or policy-related risks through grants and incentives. Development finance institutions may provide concessional loans, guarantees, or technical support. Climate funds may support projects with measurable environmental benefits. Strategic partners may contribute expertise, equipment, market access, or customer relationships. Commercial lenders and private investors generally participate as project risks are reduced. Strong financing strategies match different risks with organizations capable of managing them, creating a more balanced and bankable project structure. Organizations finance hydrogen projects for different reasons. Commercial banks focus on repayment, predictable cash flow, and financial risk. Governments may prioritize employment, industrial development, energy security, and emissions reduction. Development finance institutions seek sustainable economic development and increase private investment. Climate funds focus on measurable environmental benefits and alignment with climate objectives. Strategic investors may seek future hydrogen supply, access to technology, or entry into new markets. Developers must understand these priorities before approaching each institution. A strong proposal does more than explain how hydrogen will be produced. It demonstrates how the project delivers the specific economic, commercial, environmental, or development outcomes that matter to the potential funding partner. There is no universal financing pathway for green hydrogen. Each project has a different scale, location, technology, market, ownership structure, and stage of development. A smaller demonstration project may begin with government grants or corporate innovation funding. A large commercial project may combine developer equity, strategic investment, development finance, export support, commercial loans, and climate funding. Some developers finance the first studies internally, while others receive assistance from government programs or project preparation facilities. As technical and commercial uncertainties are resolved, larger funding sources become accessible. Financing therefore develops alongside the project, with different organizations participating as the project moves closer to bankability. Many hydrogen feasibility studies are initially financed by the companies developing the projects. Energy companies, utilities, chemical producers, industrial manufacturers, mining companies, and other large corporations may use their own capital to evaluate future hydrogen opportunities. They fund engineering studies, market assessments, environmental work, and financial modeling because hydrogen supports their long-term business plans. Internal financing allows a company to investigate the project before seeking outside investment. It also demonstrates commitment to lenders and partners. Corporations with experienced teams, existing customers, technical expertise, and strong balance sheets are often better positioned to carry early development risk while preparing the project for larger external financing. Governments frequently provide grants to address the early funding gap that prevents private developers from completing project preparation. These grants may support feasibility studies, engineering, resource assessments, environmental work, pilot projects, technology demonstrations, and other early development activities. Public support reduces the amount of risk carried by developers and encourages innovation in markets that are not yet fully commercial. Governments may also support hydrogen because projects can create employment, strengthen domestic industry, improve energy security, and contribute to climate targets. Grants rarely finance the entire project. Instead, they provide the early support needed to improve project readiness and attract large amounts of private or institutional capital later. Development finance institutions are especially important where commercial financing is limited, expensive, or unwilling to accept early project risk. These institutions may provide concessional loans, guarantees, technical assistance, advisory services, and project preparation support. Their objectives include sustainable development, infrastructure expansion, private investment mobilization, and economic growth. Their participation can reduce risk and give commercial banks and investors greater confidence in the project. Development institutions also apply detailed technical, financial, environmental, and social requirements that can strengthen project quality. For many hydrogen developments, their involvement helps bridge the gap between early feasibility work and the larger financing required for implementation and construction. Climate funds support projects that reduce greenhouse gas emissions and contribute to national or international climate objectives. They may provide grants, concessional finance, technical assistance, or project preparation support. Unlike purely commercial investors, climate funds also evaluate the environmental and development benefits of a project. Developers must demonstrate credible emissions reductions, environmental safeguards, and alignment with broader climate strategies. These funds can be particularly important where hydrogen markets remain new and conventional finance is difficult to obtain. By reducing early risk and improving project economics, climate finance can help attract development institutions, governments, private investors, and commercial lenders to promising green hydrogen projects. Project preparation facilities finance the technical and professional work required to make infrastructure projects investment ready. They may support feasibility studies, engineering design, environmental and social assessments, legal reviews, financial modeling, permitting, procurement planning, and transaction advice. These facilities normally do not finance the construction of the plant itself. Instead, they finance the information and documentation investors need before making a decision. This support allows developers to identify risks early, strengthen project design, and avoid expensive mistakes. For developers that lack sufficient early-stage resources, project preparation facilities can provide the foundation required to transform a preliminary hydrogen concept into a credible and bankable investment proposal. Strategic partners contribute more than financial capital. They may provide technology, equipment, engineering knowledge, operational experience, infrastructure, customers, supply chains, and access to markets. Potential partners include electrolyzer manufacturers, renewable energy developers, engineering companies, utilities, industrial hydrogen consumers, infrastructure operators, and prospective off-takers. Their involvement can reduce uncertainty by demonstrating that experienced organizations support the project. Strategic partners may help refine the technical design, validate commercial assumptions, develop customer relationships, and prepare for future operations. Investors often view these partnerships as evidence of stronger execution capability. Their contribution can therefore improve both project development and the likelihood of securing additional financing. Large hydrogen projects are rarely funded by one organization. They commonly rely on blended finance, where several forms of capital are combined within one financing strategy. A project may receive government grants for early studies, project preparation assistance, concessional finance from development institutions, equity from developers or strategic investors, and commercial debt from banks. Each organization participates according to its objectives and ability to accept risk. Public or concessional funding may reduce early uncertainty, making the project more attractive to private investors. Blended finance allows funding responsibilities to be shared and can mobilize more capital than any single source could provide independently. Developers often focus heavily on technology, while giving less attention to the financing system that determines whether the technology will ever be built. Every funding organization has different eligibility requirements, objectives, risk tolerance, and information needs. Grants, climate funds, development institutions, preparation facilities, strategic partners, banks, and private investors usually participate at different stages. Successful developers understand how these organizations fit together and approach them when a project has reached the appropriate level of readiness. Knowing the funding ecosystem helps developers present the right information to the right organization at the right time, moving the project systematically from feasibility toward bankability. Developed markets generally offer mature financial systems, established infrastructure, experienced engineering firms, transparent regulations, skilled workforces, and industrial customers familiar with large energy projects. Governments may further support hydrogen development through strategies, grants, incentives, research programs, and long-term decarbonization policies. These conditions can reduce risk and make commercial capital easier to access. However, competition for funding is also strong. Investors still expect credible engineering studies, realistic financial models, clear risk management plans, capable project teams, and reliable customer demand. Even within supportive markets, funding does not automatically follow technology. Projects must still demonstrate that they are commercially attractive, properly prepared, and capable of successful implementation. Emerging markets may offer exceptional renewable resources, available land, growing industrial demand, and opportunity for hydrogen production and economic development. However, projects may also face limited infrastructure, evolving regulations, higher financing costs, currency risk, and reduced access to commercial capital. International cooperation is therefore often important. Governments, development finance institutions, climate funds, project preparation facilities, strategic investors, and commercial lenders may work together to reduce risk and mobilize investment. These markets can become important hydrogen producers, but strong resources alone are not sufficient. Success depends on supportive policies, institutional capacity, infrastructure development, credible project preparation, and financing structures adapted to local conditions. The funding journey begins with an idea and an initial assessment of the opportunity. Pre-feasibility work determines whether the concept deserves further investigation. A detailed feasibility study then examines engineering, market demand, environmental requirements, costs, revenues, and financial performance. Project preparation continues through permitting, stakeholder engagement, commercial negotiations, and more detailed technical work. As uncertainty decreases, the project can track grants, strategic partners, development institutions, private equity, and commercial debt. Eventually, the financing structure is completed and the project reaches financial close, allowing construction to begin. Each stage builds evidence, reduces risk, and opens access to larger sources of capital. Many projects weaken their financing prospects through avoidable mistakes. These include unrealistic financial assumptions, incomplete engineering, uncertain market demand, underestimated costs, weak environmental analysis, insufficient stakeholder engagement, and approaching investors before the project is ready. Some developers focus on the electrolyzer while overlooking electricity supply, water, infrastructure, permits, customers, and operating requirements. These gaps increase uncertainty and damage credibility. Successful developers identify risks early, validate assumptions with reliable information, strengthen documentation, and build relationships with relevant stakeholders and funding organizations. Investors are more likely to support projects that demonstrate careful planning, transparent analysis, capable management, and a realistic pathway toward implementation. The final lesson is simple. Investors do not necessarily fund the most innovative idea first. They fund the projects that give them the greatest confidence. Strong engineering, realistic financial models, credible market demand, environmental preparation, experienced partners, and an appropriate financing strategy all work together to reduce uncertainty. Each completed development milestone strengthens the evidence that the project can be built and operated successfully. Technology remains essential, but technology alone does not create a bankable project. The hydrogen developments most likely to succeed are those that understand the funding ecosystem and systematically transform an early idea into a professionally prepared infrastructure investment.